In this video, we will be talking about the formulas needed to calculate changes in energy. The units for that are going to be the joule. We have some vocab words. Fusion and melting, solidification is freezing, vaporization is boiling, and condensation, we use the scientific word already. So we're going to be talking about the heat of blank a lot. So I use the term HX, but in reality it could be HF, HS, HV, and HC. To make life simple, we are going to shorten it to HF and HV because HC is just the opposite of HV and HS is the opposite of HF, so you don't really need to know all four. We can break it down into just two. So HF we would call the heat of fusion, that's what the F is for, and HV would be the heat of vaporization, that is what the V is for. Now what are they? The heat of fusion is the amount of energy needed to melt, because we're talking about fusion. If it was HS, we would just switch the word to freeze, that's why we can combine these, but melt 1 gram of water at its melting point. Now the reason I have a blank here is because it doesn't have to be water. The majority of the time it will be, but there is a heat of fusion number for basically every material in existence. Everything that can melt will have a heat of fusion. So the amount of energy needed to melt 1 gram specifically of water at its melting point. Heat of vaporization, it's the exact same definition, except it's the amount of energy needed to boil 1 gram of water or anything at its boiling point. And then the next definition is called the specific heat capacity. Some people say of water, it doesn't have to be. It's the amount of energy needed to raise the temperature of a gram of water by a single degree Celsius or Kelvin. They're interchangeable at this point. Okay, so those are the three definitions. Now, if you think about those definitions, and then if you think about a heating cooling curve, there's really only three things that happen to water. On a heating cooling curve, let's say we're talking about a heating curve. We start below freezing and the temperature goes up. Well, this definition handles the energy. This definition will allow us to calculate the energy gained by temperature change. Then it flattens out and melts. Well, that's what this definition is for. Then it heats up again until it starts to boil. Now we're here. Then it boils. Once it's done boiling, it goes up again. So on a heating cooling curve, you really have temperature change followed by melting, followed by another temperature change, followed by boiling, and then a final temperature change. So we use these definitions. They are unique to every material, and so therefore the actual numbers that go with these will be unique to the material. The definitions themselves never change. Now on your reference table, just to label this out, we actually have all these things right here. On table B in your reference table, it's pretty simple. The heat of fusion, write in HF so that way you never confuse it. For water is 334 joules per gram. If you think about the definition, it should explain the units. It takes 334 joules to melt a single gram of water. This number itself is unique to water. The definition is not. Heat of vaporization, that's the HV for water, write that in. It is 2,260. This is the reason why we don't merge these two definitions together, is because the numbers are very different. It takes 2,260 joules of energy to boil a single gram of water, but it takes only 334 joules to melt a single gram of ice. So we separate them out. They are wildly different. And then the specific heat capacity for water is 4.18. Now, if you think about the definition, it should explain the units. It takes 4.18 joules of energy to raise the temperature of 1 gram of water by 1 degree Kelvin or Celsius. The K and the C can be swapped. That actually doesn't matter. So we have our definitions right here, and this is what they are. Do not confuse the C for specific heat with the C value for temperature. If you're dealing with a chemical formula and they put a C in, they are talking about the specific heat capacity of water or any other material that they're referencing. If they wanted you to use the temperature value, they would put in a T for temperature, not a C. Okay, so that is a common mistake. If we go to the back of the reference table, you actually have your three specific heat formulas right here. We have heat. There's Q equals MC delta T. This formula is clearly for temperature change because it has a delta T in it. We have Q equals MHF. This formula is for melting because it has the HF, which means heat of fusion. And then Q equals MHV. The HV is heat of vaporization, so this formula is for boiling. And then it actually is nice enough to tell you all the different variables and what they are. Q is heat, M is mass, C specific heat, delta T change in temperature. See, that's why I don't confuse those two. And then HF and HV, which we already know. So here's the three formulas. We'll explain it a little bit more. So we have our three formulas here, and this is when you use them. We have Q equals MC delta T. that delta T stands for change in temperature. Delta means change, T for temperature. So we use this formula when a liquid or a water is having its temperature change. Well, it doesn't actually have to be liquid. It could be a solid or a gas as well. When anything is changing temperature, we use this formula. We use this formula, Q equals MHF. The F stands for fusion. Fusion means melting. We use this formula when there is melting only happening. Notice there's no T in this. There's no temperature change in these formulas. And then Q equals MHV. Same thing. We use this formula specifically for boiling. Now, if you notice, they're basically the same thing. And the reason is simple. They're basically the same definition. It's just the HF value for water is a different number from the HV value. So therefore, we give it two different formulas, but they're effectively the same formula, just with a different number substituted in. All right, so those are our three energy formulas. This is when to use them. These are the definitions and what they mean. Table B in your front page of your reference table, and these formulas can be found on table T in the back and an explanation of what they are.